In this demo, we will show how to configure a custom serial request-response-based protocol with an Anybus Communicator. Let's start with the serial communication settings. This is where you select the serial protocol to use. For this configuration, we will select the custom request-response mode. On the basic settings, we will change our physical standard to RS-485 and our baud rate to 19,200 baud. The remaining settings match our setup. Let's continue to nodes and transactions. Here we have our gateway, and below it we will add our serial node. The node address is 1. As it's a weight scale, I will change the name to weight scale. The rest of the settings are okay for our setup. So now I have a node. To make it talk on the serial bus, I will add a transaction. As it's a custom request and response protocol, I will have to specify how you talk on the serial communication bus. This is specified through a template. So let's add a new transaction template. We get transferred to the transaction templates window. On my desk, I have the manual for the weight scale. It tells me how the protocol is set up. In this case, there's a read command to read the current weight from the weight scale. So let's call the transaction read. Then we use the frame editor to define the read command. In the manual, I see that in the request to the weight scale, the first block of data is the so-called slave address. It's 1 byte. That matches our node address object. So I will drag the node address object into the request frame. I will call it slave address, so I remember its meaning. The next block of data is the so-called command type. It's 1 byte, so I will use the constant object and drag it down into my request frame. Let's go to the right-hand menu and change the name to command. Then I will change the fixed field setting to no, set when used. This means that I can change the command for each transaction. Just bear with me and I will show you in a few moments. Then I will add the start register object. That's also a constant object, so let's drag that down. I will change the name to match the manual. As it's 2 bytes, I will change the type to Word. Then I will change the fixed field setting to no, set when used. Next we will add an end register object, so let's drag down another constant. Let's call it end register. Change the type to Word, as it's 2 bytes. Change the fixed field setting to no, set when used. Last we have a checksum object, so grab the checksum and drag it down. It's a CRC-based checksum type that matches our default settings, so we can leave that untouched. At this point we have set up the request to the weight scale. The next step is to set up how we will handle the response that we will get back from the weight scale. In the manual I see that the weight scale shall respond with the same node address and command that was in the request. As this is very similar to the slave address object, click on the 3 small dots next to it and select Duplicate to Related Frame. Perform the same procedure for the command object. Then according to the manual, we need to add a response size. So we drag down another constant object. Let's call it byte count. According to the manual, the value should be 2. The following block of data is the weight that we want to send to our PLC. To do that, we add a data object. Let's keep the name of the data object, but change the length to 2 bytes. Then we need a checksum, so let's just drag down a checksum object. So now we have defined a template for how to send requests and handle responses on the serial bus for a read command. Next, we go back to nodes and transactions. The template we just created is already pre-selected for our transaction. To make it easy to remember what this transaction does, I will go ahead and change the name to read wait. In the template, we define that a so-called command shall be sent. Now we will define what to send for this read wait transaction. In this case, it's a 4 according to the manual. The start register shall be kept at 0. The end register shall be a 1. In the response, the command shall be the same as in the request, thus a 4. The update mode shall be cyclical, as we want the gateway to continuously read data from the wait scale. The update time defines how often the value shall be read. Now we can apply our changes and check if the serial communication is working. Let's hit the apply button and send the configuration file to the gateway. To see if it's working, we will head back to the home screen. It looks good. The serial communication is now green, data exchange is active, and the node is green too. Finally, I will go to the I/O data map to check how data will be transferred to the PLC. As you can see, the data will be transferred to the PLC on the first byte position. It's easy to change that by drag and drop or in the right-hand panel if needed. Let's check the serial log to see what's being exchanged on the serial bus. Then I hit Start to record data from the serial bus. Now the communicator can read the wait data from the wait scale continuously using the custom serial protocol and transfer the data to a PLC for processing.